This video is about differentiation and finding the value of slope at a point. First of all, a quick reminder, in our last video we said that linear functions always have the same slope. So if I differentiate, I get the slope for every point on the line. You can see here that the slope of the line, the way in which it's going upwards, isn't changing as it moves along the line. Whereas in a quadratic function, the slope of the function depends on where you are in the function. So the slope varies depending where you are in the function. It varies by location. And I told you that this particular quadratic is y equals x squared minus 4x plus 4. And we saw that dy dx equals 2x minus 4. And that we could use this to work out the slope at different locations along the quadratic. So let's remind ourselves again of how that works. For example, if I was at x equals 0, which is this point here, then the quadratic, I can clearly see it's decreasing at that point, it's sloping down. I can say dy dx equals 2 times 0 minus 4. I can say dy dx equals minus 4. Next, I'm going to take this location. It's the point 3, 1. I wonder what the slope of the function is at that point. Well, if the point is 3, 1, then it's really the x bit that I'm concentrating on. So at x equals 3, I can say dy dx equals 2 times 3 minus 4, and dy dx equals to 2. I wonder, could you identify a location on this diagram where the quadratic has a slope of 0? Take a moment to think about it and see if you can work it out. Perhaps you've successfully identified this point. It's the point at which my quadratic stops decreasing and starts increasing. It's right at the bottom of the function. I can call that its minimum point. I can see pretty clearly from my diagram here that that's the point 2, 0. But if I wasn't sure of what the value was of my x in this case, I could work it out. So if I was asked the question, where is the slope 0, which is the same as saying where is dy dx equals to 0, I could take my dy dx expression, which is 2x minus 4, I could let that equal to 0, and then I could solve that equation to find out the x value where the slope is 0. So 2x equals 4, I'll divide by 2, and I get x equals to 2. Like I said, in this particular example, it was pretty easy to see that it was at the value 2 on x, on the x-axis, but quite often you might have a quadratic or a different function where you don't have a diagram and it's not as obvious where that point is located. Now, speaking of the point, I've got the x part of the value now. If I wanted to find the full point, I'd need to get the y value as well. Well, don't forget, I know that y is equal to x squared minus 4x plus 4. So if I have x, like I do down here, and I want to get y, I can just sub the x into this equation on the very top. And when I put that into the calculator, I'm going to get a value of 0. So x is 2 and y is 0. I can say that dy dx equals 0 at 2, 0. Okay, so let's see how one of these questions might typically appear. If y equals 3x squared minus 2x minus 1, find dy dx at x equals 1. So there's two things I have to do. I have to find dy dx, and then I have to sub in 1. At this stage, pause the video and try and do that yourself, and then play and see if you got it correct. So first of all, dy dx is 6x minus 2, and now I'll use the x equals 1 value. When I fill that value in, I get a result of 4. And that's the answer for that question. That's the value of dy dx at x equals 1. This type of question might also appear as something like, if y equals 4x cubed minus 3x plus 8, find the slope of the tangent to the curve at x equals minus 1. Slope of the tangent is just a reference to dy dx, and the process is just the same as in the first example. First of all, I'll differentiate, and again, pause the video at this stage and see can you manage it yourself. Don't forget, it'll be differentiate and sub in. So dy dx is 12x squared minus 3. Make sure to put brackets around that minus 1 when you fill it in, and your result at the end is 9. So 9 is the slope of the tangent to the curve when x equals minus 1. Here's a further example. Y equals 4x minus 2x squared this time. Find the rate of change of the function when x equals 2. Again, when you see rate of change, straight away you think dy dx. So again, it's just asking you the same thing as before. Find dy dx and sub in. Again, pause the video and do this yourself. In this case, dy dx equals 4 minus 4x. And when we substitute in 2, we get a result of minus 8. So the rate of change of the function is minus 8. Don't forget, all three of these are asking you the same thing effectively. Find dy dx, find the slope of the tangent, and find the rate of change. At this stage, you should go to your book, page 517, and answer the questions on that page. You should also be able to attempt page 519, question 1.